Hi guys, I am Shaheed-Ul and I will be presenting a video lecture session today powered by our leading institution platform. We'll simulate real-world exam environments through our NEET Mock 4 physics test paper series, subsequently followed by discussion of 10 mock papers for the welfare of NEET aspirants. Dear student, please remember that practice is the hardest part of the learning and training is the essence of transformation. An ounce of practice is generally worth more than a ton of theory. We can open the doors, but you must enter yourself. Stay tuned and watch the video series to develop your skills through our rigorous practice regimen. Remember, a person who never made mistake never tried anything new. Mistakes are learning point which enhance your accuracy level. Start practicing different questions in periodic, disciplined manner. Procrastination in your study makes easy things difficult and difficult things impossible. You have a great opportunity to utilize the extra time available due to the ongoing pandemic situations this year. So make every second count. Please subscribe to the channel and hop aboard the NEET train. Also, please share the link with other aspirants so that everyone can reap the benefit of free education. Students can opt to join our free NEET mock test series. Please contact platform to avail these facilities along with supplementary doubt clearing session. We hope that our effort will help you to manage time and effort effectively, preparing you for the actual experience of being in an examination hall. It is now time for first question. So let us see the question number 1. A student measures the time period of 100 oscillation of a simple pendulum 4 times. The data set given here 90 second, 91 second, 95 second, 92 second. If the minimum division in the measuring clock is 1 second, that is the accuracy least count of this measuring clock is 1 second. Minimum that is the least count, minimum count is 1 second. Then reported mean time should be. Okay, here time, average time, it is actually 90 plus 91 plus 95 plus 92 by 4, and the average mean time is 92 seconds. The absolute error is equal to 92 minus 90, this is 2 seconds. Delta T2, it is 92 minus 91, it is 1 second. Delta 3 is equal to 92 minus 95, it is 3 seconds. And delta T4 is equal to 92 minus 92, it is actually 0. So the average absolute error in the measurement is equal to 2 plus 1 plus 3 by 4 plus 0 equal to 1.5 second. But 1.5 second cannot be measured by this clock because you know the least count is 1 second. So the right option here, it measure 92 average value plus minus 2 seconds. So right option here is 2. Next problem. Force F1 required to just moving a body up an inclined plane. In an inclined plane, force required F2 moving up is equal to, if this angle is theta, then we can write it is mg sine theta plus mu mg cos theta. In the second case, on the same inclined plane, the minimum support required to just prevent the body from sliding down the plane, the downward force along the inclined plane is mg sine theta, and the support minimum force required to prevent this body, let us say it is F2. In this case, the friction acts along inclined plane mu g cos theta. So here F2 is equal to mg sine theta minus mu mg cos theta. Required to just prevent the body from sliding down, it is double. F1 is double the force F2. F2 is the minimum support required to keep the body stationary or prevent the body falling down from the inclined plane through the inclined plane. And this force F1, according to questions it is given, F1 is equal to 2F2. So we can write here mg sine theta plus mu mg cos theta is equal to 2 mg sine theta minus mu mg cos theta. Therefore, we can write mg sine theta is equal to 3 mu mg cos theta. Finally, tan theta becomes 3 mu, and the angle of inclination theta is equal to tan inverse 3 mu, and here the correct option is 4. Moving on the next problem, let us see what is the problem. So next question, question number 3, a parachute after bailing out falls 50 meters without friction. So here parachute falls 50 meters without friction, that is free fall. We can say the velocity v square equal to u square plus twice gh. It is actually free fall. So the velocity v square equal to 0 plus 0 square 2 into 9.8 into 50, and this is 980 meter. So initial velocity after covering 50 meter under gravity, the initial velocity, the final velocity at the point after covering 50 meter, and at this point when parachute opens, the velocity finally here is the initial velocity when parachute opens at this point, and this is the initial velocity u. We can write here this is 180 meter per second. Okay, and when parachute it opens and it reaches the ground 3 meter per second. There is a retardation here, because of the friction, air friction, and the final velocity at the point is v square u square minus twice ax. X is the distance covered to reach the ground, and x is equal to, we know it is u square minus v square by 2a, and it is 980 minus 9 by 2 into 2, so therefore it is 971 by 4, and it is approximately 243 meter. So therefore total height covered before reaching the ground, it is 50 meter free fall, and the height covered or distance covered under retardation, it is 243 meter. The total height is 293 meter. The correct option here is 1. Let us see the next problem of this session. A cyclist goes round circular path of circumference 34.3 meter in root over 22 seconds. Okay. First of all, we know the circumference is twice pi r, and it is 34.3. So radius of the circular path is 34.3 by twice pi meter. And the velocity we can write, it is twice pi r by t. So actually it is 34.3 total circumference, 34.3 given in the problem, and the time taken to cover this circumference is root over 22 seconds. This is meter per second. This is the velocity of the cyclist. We know tan theta, that is theta is the angle of leaning with the vertical. The cyclist has to lean with the vertical with some angle, and this angle is theta. Then you can say tan theta is equal to v square by rg, and v square is equal to 34.3 by root over 22 whole square. The value of r is equal to 34.3 by 25, and the value of g is 10. And after simple calculation, we can write 34.3 by 22 into 10, and this is 2 into 22 by 7, and this value approximately 1. So the angle of leaning is equal to, we can write, it is 45 degree. The right option here is 1. Next problem, a reference frame attached to the earth is an inertial frame by definitions, cannot be inertial frame because earth is revolving around the sun, is an inertial frame because Newton's laws are applicable, and option 4 is an inertial frame because the earth is rotating about its own axis. Since the earth is rotating and revolving around the sun, according to definitions of inertial frame is the frame which is moving with uniform velocity, that is without acceleration. Since the earth is rotating or revolving around the sun, so it has the centripetal acceleration. So the earth itself is not a inertial frame because it has the acceleration. Any frame moving with acceleration is non-inertial frame. Any frame any frame moving with acceleration or retardation is non-inertial frame. So reference frame attached to the earth, also revolving around the sun with an acceleration, centripetal acceleration. It is non-inertial frame. So reference frame attached to the earth cannot be an inertial frame because earth is revolving around the sun. So right option here is 2. Next problem, a gas at temperature 250 K is contained in a closed vessel. If the gas is heated through 1 K, then the percentage increase it in pressure. Here closed vessel, it means volume fixed. Volume of the container is fixed. So here we can write P varies T. P is the pressure and T is the temperature of the gas. So we have to find out the percentage increase in its pressure. We can write P is equal to KT. 1 Kelvin temperature change is very small change with respect to the initial temperature 250 K. So we can say that fractional change of pressure is equal to the fractional change in temperature. K is the constants, proportional constant cannot be changed. So if we take the log and differential form both sides of the equation, we get here dP by P is equal to dt by T. And temperature change, very simple questions. Temperature change here is 1 K and the actual temperature of the gas is 250. And 1 by 250 into 100, this is percentage change in pressure. And this value becomes 0.4%. So correct option here, 1 is the right option. Next problem number 7, a ball is dropped from height 10 meter. Ball is embedded in sun 1 meter stops. So this is the questions asked in the based on the conceptual questions. No calculation is required to find out the right option here. Any collision, two-body collision, always the momentum always remain constant. That is the total momentum before collision and after collision always remain same, that is fixed. This is known as the conservation of momentum. For any type of collision, whatever may be the type of collision, momentum always remain fixed. That is conservation of momentum always remains, whatever may be the. So here the ball and earth system, if we take the for ball and earth system, we can say momentum remains conserved. So here only momentum remains conserved Right option is 1. Let us see what is the next questions here. The question number 8. Two bodies of different masses 2 kg and 10 kg are moving with velocity 20 meter and 10 meter towards each other due to mutual gravitational attraction. What is the velocity of their center of mass? You know the velocity of center of mass equal to m1 v1 plus m2 v2 vector sum of momentum by scalar sum of masses. Here 2 kg and velocity it is 20 meter. Let us say it is moving along positive x-axis, so 20 I cap plus the mass of the other body is 4 kg and the velocity it is moving opposite to the first one, so it is moving with velocity minus 10 I cap by total mass is equal to 2 plus 4. The velocity of center of mass is equal to 0. Correct option here is 4. In this type of problem, it is also the problem based on the conception. If two body moves towards each other due to the mutual gravitational attraction, if we think the mutual gravitational attraction are the internal forces acts on the system of bodies, this means there is no external forces applied on the system of bodies. So according to Newton's first law, either the center of mass of the system of bodies remain at rest or continues with uniform velocity. Since before approaching to each other, their velocity of center of mass is at stationary condition, is at rest, so we can say it will maintain its stationary condition when two bodies approach each other due to the mutual gravitation. So directly without calculation you can say the right option here, since the body moving towards each other due to the mutual attraction, that is internal forces, there is no external force applied in the system of bodies. So right option here is 4. Velocity of center of mass is always 0. It is also based on the conception, not necessary to calculate the problem velocity of the center of mass. You can directly find the answer here also. Next problem. A satellite revolves around the Earth in an elliptical orbit. Its speed, that is orbital speed. We know orbital speed V naught is equal to root over Gm by R. So we know orbital speed is inversely proportional to the root of the orbital radius. So let us move to the option given here. Is the same of all points in the orbit. So this is not the right option here. Very simple question. It is greatest when it is closest to the Earth. So this is right option. If R is less, then the velocity, orbital velocity is more. And option 3, option 4 are not the correct option here. Next problem. The moment of inertia of solid sphere of density rho, radius r about its diameter is solid sphere. Moment of inertia for solid sphere, it is 2/5 mr square (2/5 and the mass of the body given, sorry, this is mass of the body are not given here, in the mass is given in the terms of density and radius. So mass can be replaced by 4 by 3 pi r q into rho into r square, and it is 2 by 5 4 by 3 22 by 7 rho r to the power 5, and it is 176 by 105 rho r to the power 5. Simple questions, straightforward questions. You have to just put the values of pi and the mass of the sphere m, 4 by 3 pi r cube into rho in terms of density and radius, and the correct option here is 3. Next problem. The ratio of velocity of electron in first orbit to that in the second orbit here. We know orbital velocity of an electron around nucleus V is inversely proportional to the quantum number. N is the quantum number, that is you have to put the value 1, 2, 3, orbit number 1, orbit number 2, orbit number 3. Okay, here ratio first orbit to the in the second orbit, it is V1 by V2. So if we want to solve this problem, we should know the orbital velocity of electron, how it is depends on the quantum number, and directly you can say V1 by V2, it is actually N2 by N1 and orbit 2 by orbit 1. The velocity of the orbital velocity, ratio of the orbital velocities of electron around the nucleus in first orbit to that of second orbit is it actually 2:1, so 3 is the right option here. Moving on the next problem. A particle of mass m is hanging vertically by an ideal spring of force constant k. If the mass is made to oscillate vertically, its total energy. You know, in the case of oscillation, spring constant k, the total energy of oscillation half m omega square s square, it is constant all time. Here you know A is the amplitude of oscillation. Simple question, very simple question as per the NEET pattern, and omega is the angular frequency, and it is root over force constant by m. So we can write this, it is half k square. So this total energy always remains fixed, that remains constant at any point. We can get the change in the potential energy and the kinetic energy of the particle oscillating under oscillating attached to the one end of the spring. So we can get the variation of potential energy and kinetic energy, but the total energy, you know, all time remains constant. So right option here, same at all points, same at all positions. Okay, so option here 4 is the correct option. Next, question number 13. A hollow metal sphere of radius 5 cm changed such that potential on its surface is 10 volt. The potential at the center of the sphere, you know. Since this sphere is a hollow sphere, it is hollow sphere, and the charges resides over the outer surface. Since this body number 1 is hollow and number 2 it is conducting body, metal body, so it is conducting body. So all time the charges resides over the outer surface of the sphere. Electric field inside this, according to Gauss law, you know, no charge is enclosed by the Gaussian surface. So electric field inside any point of the sphere is always 0. And we know electric field is the negative gradient of potential difference. Electric field in an electric field, if we take the potential gradient, so the negative potential gradient is in an electric field is equal to the magnitude of the electric field intensity. Since this electric field is 0, we can write here dV equal to 0 and V equal to constant. So at any point inside this, the potential is constant. Let us say on the surface, what is the potential on the surface? The potential on the surface, it is simple, 1 by 4 pi epsilon 0. If the total charge resides over this is q, then we can say it is the 1 by 4 pi epsilon 0 by r. R is the radius. I must say here that r is the radius of the sphere. So the potential on the surface of the sphere is 1 by 4 pi epsilon 0 q by r. And the surface is also the part of the body. It is the outermost point. Surface is the outermost point from the, if we proceed from inside and along the radius, and any point on the surface is the outermost point on the body. If the potential at the outermost point of this body is the 1 by 4 pi epsilon 0 q by r, then the potential inside any point will remain constant. So the potential at any point also, it is 1 by 4 pi epsilon 0 q by r. So it is the potential, it is the potential at any point inside, at any point inside sphere, at any point inside sphere. So the right option here is 2. Potential on the surface is 10 volt. So the potential inside this sphere is also 10 volt. Next problem of this video session, the electric field region is given by E. It is variable electric field, you know, alpha xi cap, where alpha is a constant of proper dimension. Find the total flux through a cube bounded by the surface. If we place a cube here, and you know this is along x direction, electric field is variable electric field. The magnitude of the electric field changes along x-axis directly proportional to the x. So electric field entering E1 flux entering through the surface YZ plane, through the YZ plane of the cube, the unit vector, the YZ plane, that is the area is L square, and the perpendicular to the surface is along the x-axis. If we take the plane is this surface is a vector quantity, aerial vector. So if we draw a normal, and the direction of normal is the direction of the aerial vector. So flux entering, it is phi1 is equal to, you know, E1 dot A vector. Here E1 is equal to bounded x is equal to L. So E1 vector is equal to alpha L I cap. It is the electric field. Since this cube is bounded, x is equal to L dot L square I cap, because normal vector is along the x-axis. This is YZ plane. So flux entering into the cube alpha L square, sorry, I am correcting myself, alpha L cube. It is the flux entering into the surface of the cube. And flux leaving the surface. Flux leaving the surface. Phi2 E2 dot A vector, aerial vector, bounded up to x is equal to 2L. So electric field also changes at this surface. Electric field becomes alpha 2L I cap dot L square I cap. So we can write 2 alpha LQ is the flux leaving the other surface at x is equal to 2L, but one is entering, other is leaving. Here, as per the convention, if we take entering, normally it is taken entering, flux entering into any surface is negative, and flux leaving any surface is taken as positive. So the net flux passing through cube, we can write here, it is equal to phi2 minus phi1. And the right option here is alpha L cube. Option 1 is correct option. Alpha L cube is the neat flux passing through the cube. Next problem. Question number 15. When an ideal gas exponent gamma given within the bracket 5/3, I think it is monatomic gas, is heated under constant pressure, then what percentage of given heat energy will be utilized in doing external work? Let us discuss some theoretically. Gamma, gas exponent Cp by Cv. N is the number of mole, it is Cp, and the temperature change, let us say del T, since the heat is supplied to the gas at constant pressure, so Ncp del T by Ncv del T, and it is actually heat supplied at constant pressure, and this is actually heat supplied at constant volume. This can be written as total heat supplied, and this is the change of internal energy. From the first law of thermodynamics, del Q is equal to del U plus del W. So del U by del Q, that is the change in internal energy by total heat supplied to the gas, is equal to 1 by gamma. It is very important. Gamma represents the ratio of the heat supplied to the gas at constant pressure and to the heat supplied at constant volume. Conceptually, gamma, the value of gamma is equal to Cp by Cv, but conceptually gamma signifies that the ratio of the heat supplied at constant pressure to the gas and the ratio and the heat supplied to the same gas at constant volume. So the fraction of the energy utilized to the total heat supplied is equal to 1 by gamma. Similarly, the other part from the first law of thermodynamics, del W by del Q is equal to, actually it is 1 minus 1 by gamma. So this is very important. Conceptually, it is very important. Formula, del U by del Q, fractional change, fraction of the energy utilized to change the internal energy to the total heat supplied is equal to 1 by gamma. And similarly, work done by total heat supplied, fractional work done to the total heat supplied, we can get from 1 minus 1 by gamma. Here in this problem, what percentage of heat energy will be utilized in doing external work? So work done by directly, we have to utilize this. It is 1 minus 1 by gamma, and it is 1, and the value of gamma given in this problem is 3 by 5. So this is 2 by 5, and in percentage it is 40% of the total heat supplied is utilized in doing the work. Okay, right option here is 1. So this question is also based on conception. You should have this conception, the significance of gamma, and little bit calculation, or sometimes some student can do this problem without calculation. because very simple, 1 minus 3 by 5, it is 2/5, 2/5 is 40%. Okay, next problem. 4 pieces of iron heated in furnace to different temperatures, so different color listed below. Which has the highest temperature? You know, radiation, with the rise of temperature, the wavelength of radiation goes on decreasing with the rise of temperature of body, according to Wien's law. So, with the rise of temperature, if any body is heated, so first color we get red, then you write here VGO, you know, wavelength increases, so wavelength of red is highest and the wavelength of violet is least. So if the temperature of the body goes on increasing, first we get the red radiation, then we get orange, then we get yellow, and in this way, when all types of wavelength is, all types of radiation, all types of all colors are radiated by the body at a very high temperature, the lights become white. At very high temperature, any body emits all types of radiation from red to violet, so the light appearance of the body, the white light radiation can be found from the body at high temperature. So the correct option here is 1. So when the body emits white light, in this case the temperature of the body is highest. Next problem. Water rises to a height h in a capillary tube of area of cross section A. To what height will water rise in a capillary tube of area of cross section 4A? You know, the ratio it is actually A by 4A, ratio of radius, it is half, and you know, in the capillary rise, height of water column height of liquid column h is inversely proportional to radius of the tube as per the Jourin's law. So H2 by H1 we can write is equal to R1 by R2, and h2 is equal to h1 by 2, and the given h1 in the problem given is equal to h, so the right option here is h by 2. Correct option is 2. Moving on the next question of this session, question number 18. If two spring A, B with spring constant 2k and k are stretched separately by same suspended weight, then the ratio of the work done in stretching. You know, we know F is equal to kx. F here in the problem given is weight. So, energy half into F into x1 by half into F into x2 under the same tension or under the same weight. Both the spring are stretch, so the ratio of the work done stretching A and B, that is equal to ratio of the expansion. And you know, under the same weight we can say k1 x1 is equal to k2 x2 under same weight. So x1 by x2 is equal to, we can write k2 by k1. This is k by 2k given in the problem. This is 1 by 2. Correct option here is 1. 2, 3, 4 are not the correct option. Next problem. When wave travels in a medium, particle displacement given by the equation where A and B constant, the maximum particle velocity will be twice the wave velocity. Before solving this problem, generally we know the standard equation of wave is equal to y equal to a sine omega t minus kx. Here y actually, all time you should keep in mind, y actually displacement of particle. Displacement of particle. Y is the displacement of the particle at the path of wave. This is the equation of progressive wave, but y is the displacement of the particle at the path of wave, and x is the displacement of wave. So differentiating both sides with respect to time, dy dt, it is actually omega a cos omega t minus ks. Dy dt is the particle velocity at the path of wave. When particle oscillating, the particle also has the velocity. Particle velocity is equal to omega a cos omega t minus kx, and you know maximum particle velocity maximum particle velocity for any particle oscillating in simple harmonic motion, the maximum particle velocity is equal to omega a. It is the maximum particle velocity. The maximum value of cos function is equal to 1, so omega a. Since this particle oscillating at the path of wave, we know wave velocity V is equal to actually omega by k. Omega is the angular frequency and k is the wave number. So we can write here angular frequency omega is equal to kV into a. And very important, you can say it is advanced formula here, an effective formula, particularly in the examination hall for this type of question. It is already asked in the previous year's questions also it is. So maximum particle velocity by wave velocity is equal to k into a. It is very important formula. My suggestions to my all students, you keep this formula, very important formula, maximum particle velocity by wave velocity ratio all time, it is twice pi by lambda. Lambda is the wavelength of the wave and a is the amplitude of the particle oscillating, that is the amplitude of the wave also. So this is very effective formula or instrumental formula. You have to apply in the examination hall for this type of questions and keep this formula special. Maximum particle velocity by wave velocity is equal to twice pi by lambda. K is the wave number, that is twice pi by lambda into amplitude of the oscillation or amplitude of the wave. And here in this problem, K into A is equal to Vp max solution of this problem. You should write only this. Maximum particle velocity by wave velocity, and it is given in the problem, it is equal to 3. Maximum particle, it is 2, twice. It is given in the problem, it is twice, 2. And K in this problem, it is equal to twice pi C. And amplitude in this problem, it is A. So simply the C becomes A by pi. C equal to, C is equal to 1 by pi A. So going through all options, we immediately get c is equal to 1 by pi a. So the right option here is 1. Next problem, two sinusoidal waves with same wavelength and amplitude travels in opposite direction along string with speed 10 meter per second. If the minimum time interval between two instants when the string is flat, that is two sinusoidal waves, same wavelength, traveling through the string this is two flat positions. The time gap is equal to 0.5 second, and you know this is the t. It is actually half of the time period between these two flat positions of the string at an instant. So time difference between two instant when a string is flat. It is actually t by 2. So the time period is equal to 2 into t, and 2 into half equal to 1 second. We have to find out here wavelength. Wavelength is equal to, we know velocity of wave by frequency, and it is equal to v into t. Since we know that frequency of wave is equal to 1 by t, reciprocal of the time period, so we can say the wavelength lambda is equal to vt. And velocity in this problem given is 10, and the time period in the case of the stationary wave, that is standing wave, two waves moving opposite direction from opposite direction through the string, and the time period given in this problem and calculated in this problem is 1 second. So the wavelength of the wave is 10 meter. Next question. Question number 21. Hailstones are observed to strike the surface frozen lake at 30 degree with the vertical and rebound at 60 degree with the vertical. Assume contact to be smooth. The coefficient of restitution is. We have to find out the coefficient of restitution. And before solving this problem, here I discuss about the theoretical background of collision, particularly in this type of problem. You know, in the case of collision between ground and ball strikes at a speed u, let us say with an angle with the vertical theta, and reflected with the velocity, let us say v, with an angle phi. For this two-body collision, normal reaction act by the ground on the body is n. And if we apply the conservation of momentum along the horizontal direction, since there is no external force act along the horizontal direction, so along horizontal direction, external force on the body is 0, so we can apply conservation of momentum along horizontal direction. So mu sine theta is equal to mv sine phi, and from this equation, from the conservation of momentum, u sine theta we can write is equal to v sine phi. This is 1. And from first law of collision, we know relative velocity after collision is directly proportional to the relative velocity before collision and opposite. So after collision, relative velocity v cos phi minus 0, 0 is the velocity of ground before collision, after collision, and it is equal to E. E is the coefficient of restitution according to the first law of collision by the Newtonian mechanics. E into velocity of ground, this is 0 after collision since it is opposite, relative velocity is opposite, minus u cos theta minus u cos theta. So here we can say v cos phi is equal to eu cos theta. So in this collision, two important equation, it is equation number 2 and equation number 1. Squaring and adding, if we 1 and 2 is both the equation are squared, and after addition we get v square equal to u square sine square theta plus e square cos square theta. So the velocity after collision of the ball is equal to u root over of sine square theta plus e square cos square theta. Though it is not asked in our problem, but you know, sometimes question is asked what will be the velocity after the collision, and dividing 2 by 1, we get tan theta by E is equal to tan phi. So E is equal to, we can write tan theta by tan phi. So two important formula in this type of problem, collision between hailstorm and ground or ball with the ground. Velocity after collision is equal to v is equal to u root over sine square theta plus e square cos square theta, and the coefficient coefficient of restitution is equal to tan theta by tan phi. So basically this two formula is very important formula, advanced formula you have to apply in this type of problem if the question is asked in the examination. Now let us see what is the problem given. The problem here, we have to find out the coefficient of restitution. Okay, so coefficient of restitution directly we can find here directly E equal to tan theta, theta is the angle before collision, and tan phi is the angle after collision with the vertical. So it is tan 30 given in the problem and tan 60. So the answer is 1/3 and the correct option here is 2, is equal to 1/3. Next problem. A capacitor is charged by using a battery which is then disconnected. A dielectric slab then introduced between the plates which results in in any condenser, the condenser is charged by a battery, that is charge in the condenser is Q. Here we can say this is switch off condition. Since the battery is disconnected, we can say this is switch off condition. In this switch off condition, it is Q is equal to CV and this value is fixed. So this is the problem under control charge. Whatever may be the alteration is happen here due to the insertion of the dielectric inside the condenser. Since due to now we have to find due to insertion of dielectric, we know capacitance becomes K times capacitance without dielectrics. Reduction of charge on the plate and increase of potential difference across the plate. Since there is no change in the amount of charge in the plate, since this battery is disconnected and the condenser is fully charged, and after that the battery is disconnected, so the total charge on the plate on the condenser remain unchanged. So right, and option 1 is not the correct option. 1 is not the correct option. Increase in potential difference across the plates and reduction in stored energy, but no change in the charge on the plates. Let us check the second option, increase in potential difference. We know potential difference is equal to Q by C prime, it is Q by KC, and we know it is previous potential of the battery is V, then we can say the potential decreases by K times. So there is no question arise that the potential is increase in potential difference. So option 2 is also not the correct statement of this problem. Decrease in potential difference across the plate. Decrease in potential difference across the plate. So this is the right option or right statement of this problem. Reduction in stored energy but no change in the charge on the plates. We have to check the energy. The expression of energy we have to write here in terms of the charge, because here the charge control problem. So energy we can write is equal to Q square by C prime, and it is half Q square by Kc, and previous energy, let us say half Q square by C, then energy U by K, and energy also reduced by K times. So decrease in potential difference across the plates, it is correct statement, and reduction in stored energy, it's also correct statement, but no change in the charge on the plates. I have already told that the charge remains same, so the option 3 is the correct option. 4 cannot be predicted, it is not also the correct option, so 3 is the right option here. Next problem. A star emits light 5500 Armstrong wavelength. It appears blue, an observer on the earth. It means appears blue, we know Vibgir average sensation of star from the earth. If we see a star on the sky, then with the sensation of light in a human eye, normally it is average sensation, it is yellow. Since it's appear blue, so we can say wavelength decreases. Hence, frequency of light increases, and frequency is increases when source is moving towards observer. Frequency increases when source is moving towards observer. Frequency of light is increases when light source moves towards stationary observer, and frequency decreases when light source moving away from the stationary observer. So this is also the conceptual questions. They are not necessary here to calculate it. No calculation is required in this type of problem. You just apply your conception. When any light source or sound source moving towards the stationary observer or listener, frequency increases, and when it moves away, frequency decreases, and hence the wavelength increases. Since the wavelength decreases, blue shift, it is actually problem based on the blue shift. There are two type of shifting you can get, blue shift, and other type of shifting is known as red shift. Here the fact is based on the blue shift, so the wavelength decreases. You have to take the average sensation of the light is yellow, and from yellow, if we move towards the blue, then wavelength decreases. So right option here is star coming to forwards earth. So 3 is the correct option. Next problem. 3 capacitor, 2 millifarad, 3 millifarad, 6 millifarad joined in series and combination charged by 24 volt battery. We have to find out the potential difference. Theoretically, 3 condensers C1, C2, C3, it is charged by battery V or potential difference V. Then potential difference across C1 is V1, similarly it is V2, and it is V3. We have to find out the potential difference across the condenser. Here V1 is equal to, I must discuss V1 is to V2 is to V3. It is actually inverse proportion of the capacitances. So potential divides into parts, potential divides into 3 parts in inverse ratio of the capacitances. In the case of the series combination, potential divides into parts. Okay. Since the potential divides into parts and it is in the inverse ratio of the capacitances, charge is same for all condenser, charge same, but potential divides into parts. So by simple arithmetic, V1 is equal to V1 plus C1 1 by C2 plus 1 by C3, and similarly V2 equal to V1 plus C2 1 by C1 plus 1 by C3, and V3 total potential V into 1 plus C3 1 by C1 plus 1 by C1 plus 1 by C2. Here we have to find out the potential difference between the plates of 6 millifarad. So potential difference, if we take it is V3, then this is 24. If we apply this formula according to the features of these combinations, here the charge is same and potential divides into parts in inverse ratio of capacitances, and the potentials across the capacitances are V1, V2, V3. And if we apply this formula directly, so 24, it is 1 plus C3 is equal to 6, it is 1 by 2 plus 1 by 3, and 24 by 6, and answer is 4 volt, and here right option here 1. Moving on to the next problem, let us see what is the question here. Question number 25. Potentiometer consists of a wire of length 4 meter and resistance 10 ohm. So in the case of potentiometer wire, the length is 4 meter and the resistance of the potentiometer wire is 10 ohm. It is connected to a cell of EMF 2 volt. Since there is no internal resistance of the cell given in this problem, so the total 2 volt potential dropped across the potentiometer of length 4 meter. Okay. Simple, very simple questions. Potential difference per unit length. Then this means we have to find out the potential gradient across the potential gradient of the along the potentiometer wire. So potential gradient, very simple questions here asked. Potential gradient across the wire, potential drop across the wire is V. Potential difference across the wire is 2 volt. That is, let us say it is V, and the length of the wire is L. Whatever may be the resistance, it is 10 ohm, 5 ohm, whatever may be the, doesn't matter. The potential across this, the potential will be drop across this wire, and potential is 2 volt and the length of the wire is 4 meter, and simply it is half volt per meter. So this is too much simple question asked. Correct option is 1. Let us move next problem. The resistance in the 2 arms of meter bridge are 5 ohm and R ohm. When resistance R is transmitted with an equal resistance, the new balance point is 1.6 L, let us say it is L. Here resistance of left part it is P and the resistance of right part is Q. So if we resistance of the wire of the meter bridge left side it is taken P and the resistance of the right side it is taken Q, and let us say the resistance of the left hand side it is X and resistance of the right hand side it is Y. So simply Wheatstone bridge you know P by Q is equal to R by S, but I have taken here R equal to X and right hand side resistance is taken, it is actually Y. This is X by Y, we can write it is L by 100 minus L. So 100 by L equal to Y by X. So 100 by L minus 1 equal to Y by X. L equal to, we can say, hundred by L equal to X plus Y by X. So the balance point here, the balance point, the length of the balance point from the left hand side, if it is taken L, then we can say L is equal to 100 X by X plus Y. So it is very important. L, it is the length of the null point or balance point in the meter bridge on the basis of the Wheatstone bridge principle, you know. So in this way the problem can be solved easily if we take this formula. It is 100 X by X plus Y. And the second point, as per the first point, you know, at the first stage of this problem, 100 X is equal to, given in this problem, is equal to 5, and it is 5 plus R. I have taken this R as an Y, and the 5 ohm taken in this problem is X. And the second stage of this problem, it is 1.6 L. You have to apply this formula in the examination hall. This is the length of the null point from the left hand side of the, that is the length of the balance point. I have taken the X, that is the resistance of left hand side R, and resistance of the right hand side, normally it is taken S, but here I have taken Y. So the simple formula you have to apply in this type of problem. 1.6 L, it is 100 The resistance of left hand side, it is 5 ohm, but resistance of left hand side, it is 5 ohm as it is, but the resistance of the right hand side branch, it is when the resistance R is shunted with an equal resistance. Shunted means another resistance R is connected across it parallelly. So the equivalent of this resistance, that is Y, becomes R by 2. So simply 1 by 6 equal to, dividing these two equation, we can do this job. It is 5 plus R by 5 by R, 5 plus R by 2, and you know this is 8 by 5 and 5 plus R by 5 plus R by 2. Calculating this, 40 into 4R, 25 into 5R, and the resistance R is equal to 15 ohm. Here the right option is 15 ohm. Next problem, if two streams of proton, you know proton also having the charge, the magnitude of the magnitude of the charge of proton is same as the magnitude of the charge of electron, you know. So we can get the electrostatic repulsion between these two charges, and you know like parallel current attract each other. So we can get the magnetic force for the like parallel currents, since both the positive charge are moving parallelly. So we get the magnetic force between these two charges as well as electrostatic force between these two charges. But here electrostatic force is greater than Fm. So electrostatic force dominates over the magnetic force. Though the like parallel current attracts each other due to magnetic force, but here due to electrostatic force, these two charge feels an electrostatic repulsion, and this electrostatic repulsion dominates over the magnetic force. So right option here, repel each other. 2 is the correct option. Normally in this type of problem, student may find answer attract each other, but this is not the right option. Here you have to consider also the electrostatic force between these two charges. Next problem, which of the following characteristics is not associated with ferromagnetic material? This is also based on the theoretical questions. You should have the theoretical or the characteristics of the ferromagnetic material, paramagnetic, diamagnetic materials. My suggestions, you just go through your basic text or NCERT textbook. In the case of ferromagnetic substance, you know, it has the magnetic permeability mu R is greater than 1. In the case of ferromagnetic material, and susceptibility, it is the intensity of magnetization by magnetizing field. It is known as susceptibility. It is also greater than 1. And let us check the option here. It is strongly attracted by the magnet. It is actually right statement but wrong answer. It tends to move from a region of strong magnetic fields to a region of weak magnetic field. It is wrong answer, wrong statement but right answer. It tends to move from a region of strong magnetic field to region of weak magnetic field. Normally, if we put a diamagnetic material into the magnetic field, diamagnetic material moves from stronger zone to weaker zone, but in the case of the ferromagnetic metal, it will move from weaker zone to stronger zone of magnetic field. So the two option is not the right statement but the correct answer. Okay. And I must say the ferromagnetic reason for the ferromagnetism or the characteristics of ferromagnetic materials, the behavior of the ferromagnetic materials is due to its origin is the spin of electrons. Basically, it is due to the spin of electrons, and from the Curie law, we can say also above the Curie temperature exhibits paramagnetic properties. So ferromagnetic material becomes paramagnetic above the Curie temperature. Up to the Curie temperature, it shows the ferromagnetic characteristics. So right option here is right option here is 2, though it is the wrong statement about the ferromagnetic material, because here the question is asked is not associated. Okay, be careful about it. It is not associated. Next problem. If a coil of metal wire is kept stationary in non-uniform magnetic field, then an EMF is induced in the coil. Faraday's law, induced EMF is equal to rate of change of magnetic flux. So we need the rate of time varying magnetic field. We need, if we want to get the induced potential or induced EMF across any within any coil or across any conducting bar, then the bar or the conducting body or the coil should be passed through the magnetic time varying magnetic field pass through this coil or through the conducting bar. So an EMF is induced in the coil. Here the non-uniform magnetic field. Non-uniform magnetic field means it has the gradient, that is the space gradient. Magnetic field has the different point and different space at the different points of the space are different. So magnitude and direction, both we can say magnitude and direction of the magnetic field at the different point are different of the space. So it has the space gradient. Non-uniform means space gradient. Magnetic field has the space gradient. So there is no rate, there is no change of magnetic field strength with respect to times. So an induced EMF is induced in the coil. It is not possible if we want to get the induced EMF, then we need the time varying magnetic field. So an EMF is induced in the coil is not the right option. A current is induced, no question arises. Neither EMF nor current is induced. 3 is the right option. Both EMF and current is induced. It is also not the correct option. Next problem. An electric bulb has a rating of 500 watt 100 volt. It is used a circuit having 200 volt. So we know rating formula. Rating formula is equal to V square by R. Resistance given in the electric lamp, it is actually V square by P, and V, it is 100 into 100 by power, it is 500 watt, and 20 ohm. So it can tolerate only 100 volt, but it is used in a circuit having the potential 200 volt. So it is double. So if we want to get the full, utilize the full power of this lamp, it has the resistance 20 ohm. It is placed in 200 volt. It is placed in 200 volt. So this lamp can tolerate only 100 volt. So it can drop 100 volt at full utilization of its power. As per the power, it can deliver 500 watt at 100 volt. So if this lamp drops 100 volt, then the power of this lamp becomes 500 watt. And the resistance of this bulb is 20 ohm. So the another resistance you have to add so that the potential across this lamp should not exceed 100 volt. So here, if the potential 100 volt here, then the rest 100 volt will be dropped across the resistance added with the lamp. If the potential, potential difference is 100 volt, potential difference is 100 volt. The resistance of this lamp is 20 ohm. Added is calculated. So the resistance should be added in series with this lamp. It is also 20 ohm. As we know, potential divides into parts in direct ratio of resistances. So right option here is 2. Next problem. Ratio of specific charge of an alpha particle to that of proton. Specific charge of alpha particle. Specific charge to that of proton. Charge by mass. Charge per unit mass is known as specific charge, and it is charge per unit mass for proton. Alpha particle, it is the charge 2e and the mass is 4 mp, that is the mass of proton. Mass of proton or mass of Newton, roughly we can say the mass of the helium particle is equal to the 4 times the mass of the proton. And the charge of proton, E, and the mass of proton is mp. So therefore the right option here is equal to 1:2. Be careful to though it is very simple problem, but you should have sincerity to find the answer here, because here 2 types of option given. One is 2:1 and other is 1:2. So be careful about it. Ratio of what? Ratio of the alpha specific charge of alpha particle to the specific charge of proton. So the right option here is 3. Next problem, number 32, based on the photoelectric effect. And the question says photons of energy 6 eV are incident on a metal surface whose work function is 4 eV. The minimum kinetic energy of emitted photoelectron will be. Here we know Einstein's equation. Maximum kinetic energy of electron equal to energy of photon minus work function. That is the energy work function is the, as per the definitions, the minimum energy required to eject an electron from the metal surface. If the energy required is minimum, then the kinetic energy of electron is maximum. But here the question is asked the minimum kinetic energy. Minimum kinetic energy of emitted photon electrons will be, in case of photon is incident of an electron, if the energy required is minimum to eject the electrons, then as per the definitions it is work function. But sometimes the total energy of photon may be utilized to eject the electron of inner orbit, or total energy of the photon may be utilized to eject out the electron from the inner orbit of nucleus. So in this case the energy of electron is 0. Just it will come out of the atom, and the minimum energy of electron is equal to 0. That is, we can get the photoelectrons of energy, different energy, from starting from 0 to maximum kinetic energy as per the Einstein equation. This is the equation of the energy of electron for maximum kinetic energy. But photoelectrons we can get incident upon the photons on the metal surface. We can get the photoelectrons of different energy starting from 0 to maximum kinetic energy. So here question is asked is minimum kinetic energy. So answer is 0 eV. This is not 2 eV. 2 eV is the maximum kinetic energy of electron, but the minimum kinetic energy of electron is 0 eV. Next problem. Which of the following phenomena suggests the presence of electron energy levels in atoms? Radioactive decay, isotope spectrals, lines, and alpha particle scattering. Radioactive decay is the phenomenon of nucleus. Alpha particle scattering also the phenomenon of nucleus. So here presence of electron energy levels in atom when external energy is applied or incident upon the atom, so electron can come out from the electron can be excited to higher state, and if the electron is due to the transition from higher state to lower states, we can get the photon, or if it's in spectral analysis we get the spectral lines of the photon. So therefore the right option here is spectral lines. Next problem. Question number 34. Half-life of radioactive sample when activity of material initially was 8 counts and after 3 years it becomes 1 count is. So we have to find out here how many half-lives is involved here. We know in the formula for activity A and initial activity A naught, this can be written as to the power n, and n is the number of half-lives initially the activity is 8 counts and after 3 years the count is 1, so it is 1, and in this way you can write half to the power 3, and n is the 3, that is n is the number of half-lives. You know, number of half-lives is equal to total time taken by T half. Here the total time taken is 3 hours. It is 3 hours, and half-life according to this from this formula, we know the half-life n is equal to total time taken by T to T half, that is n is the number of half-lives. So we can write from this equation T half-life is equal to total time by number of half-lives taken to degenerate. So here the total time taken is 3 hours, so 3 by 3, and the half-life of the radioactive material is 1 hour, and the correct option here is 2. Next problem, question number 35. The energy of radiation emitted by lead is. So before going through the option given here, let us discuss about how the lead emits energy or radiation. Here we know, as per the band theory, it is CB, and the lowest energy of CB band is AC, and this is VB, valence band. The highest energy of valence band is EV, and band gap or energy difference between the highest energy level of valence band and lowest energy level of conduction band, it is actually known as EG, that is band gap energy. Here, when electron from conduction band jumps into the valence band, if the semiconductor is excited externally in forward bias, electron may jump from conduction band to valence band. When due to the transition of electron from conduction band to valence band, we can get the radiation emitted by the lead, that is light emitting diode. So the energy of the radiation emitted is equal to the band gap. This is actually answer. We can say always equal to band gap of the semiconductor used, but before choosing the right option here, I must go through all the options given greater than the band gap of the semiconductor used. It is not true, because energy emitted by the radiation is equal to band gap. Always less than the band gap of the semiconductor used, it is also not true. Always equal to the band gap of the semiconductor used, equal or less than the band gap of the semiconductor used. Sometimes transition can be taken place from the acceptor band, or maybe taken transition of electron may be taken place from the donor levels energy and acceptor level energy. We know due to the doping, when a semiconductor, intrinsic semiconductor is doped, so there are two type of energy levels, donor energy levels and acceptor energy levels, and because of that, electron may jumps from donor level to valence band or acceptor level to valence band. So this is why the energy radiation emitted by lead, it is equal to or less than the band gap of the semiconductor used. So right option here is 4. You can write down here the energy emitted by lead is equal to or less than the band gap energy because semiconductor also has other energy levels due to donor or acceptor energy levels donor energy levels lies just below the conduction band and acceptor energy levels just lies above the valence band. So transition of electron may taken place from conduction band to valence band or from donor energy level to valence band. So this is why the energy radiation emitted by lead is equal to or less than the band gap of the semiconductor used. Okay, so right option here is 4. 3 is not the 3 is also the right statement, but it is not accurate answer. It is more accurate answer is 4. So 3 is not the answer, though it is not incorrect, but it is not the answer. Okay, next problem. Consider an NPN transistor amplifier in common emitter configuration. The current gain of transistor is 100. So current gain beta equal to IE by IB, that is emitter current by base current, beta equal to collector current by base current. IC is the output current and IB is the input current, and the ratio of the output current by input current is beta, that is current gain in the common emitter configuration. Okay, and in this problem we can find the base current is equal to IC collector current by beta. IC given in this problem is 1 milliampere by 100. So it is 0.01 milliampere. So base current is 0.01 milliampere. What will be the change in emitter current? If the collector current changes by 1 milliampere, it is actually given in the problem, it is actually change in collector current and change in base current. Change in collector current or change in base current. So change in base current is equal to 0.01 milliampere. What will be the change in emitter current? The change in emitter current IE is equal to, we can say, del IC plus del IB. Del IC given in the problem is 1 milliampere and change in base current already calculated, 0.01 milliampere, and finally the answer is 1.01 milliampere, and the correct option here is 2. Next problem of this video session, the mean free path of molecules of a gas of radius r is inversely proportional to mean free path that is the mean path traveled by molecule between successive collision, and it is 1 by root over 2 pi n d square. Here n is the number of molecules per unit volume. Simply we can say n is the number density of molecules. It is number density, and d is diameter. So you can get this basic equation, lambda is equal to 1 by root over 2 pi n d square. In your basic text, you just go through the basic text or NCERT textbook. So the mean free path lambda is equal to 1 by root over 2 pi n d square, where n is the number of molecules per unit volume, it is number density, and d is the diameter. And directly question asks directly based on this equation, based on this formula, and it is inversely proportional to r square. R is the radius. Let us see what is the next problem here. Diminished virtual image can be formed only in, it is the problem also based on the conception. In the case of plane mirror, you know, plane mirror magnification is always 1. A concave mirror it is also known as converging mirror. Very simple question. In the case of concave mirror, the magnification may be less than 1, may be greater than 1, or may be equal to 1. It is for real image. If the real image is formed due to reflection by converging mirror, then we can get the magnification of real image is less than 1, greater than 1, or equal to 1. M greater than 1, converging mirror can form virtual image having the magnification always greater than 1. So it is for virtual image. It is for virtual image. And convex mirror, it is also known as diverging mirror. We know diverging mirror always forms the magnification of image is always less than 1, and image is always virtual. Convex mirror cannot form a real image of real object. It can form real image, but if the object is real, it is always form virtual image having the magnification less than 1, and it is always the magnification of the image is always less than 1. So the right option here, diminished virtual image. So right option here is 3. So this problem is also based on the conception. If you know, this is the basic conception based on the mirror. Next problem, double convex lenses are to be manufactured from glass of refractive index 1.55. It is not 1.5. Normally refractive index given in the problem, the maximum problem 1.5, but here the refractive index given in this problem is 1.55. This lens is equiconvex lens. Equiconvex lens. In the case of equiconvex lens, lens maker's equation we can write 1 by f mu minus 1. This is 2 by r. R is the radius of curvature. Since this lens is, by default we have to take the lens is immersed in air. So this part is positive and this part is positive. So focal length is also here is positive. When lens is placed in air or immersed in air, by default the convex lens have the nature which is converging in nature. So focal length here is 1 by 20. It is actually converging. It is converging in nature, and focal length is 1 by 20. And refractive index given is equal to 1.55 minus 1. This is 2 by r, and it is r equal to, we can say, 2 into 0.55 into 20. And this becomes, through the simple calculation, this is 22 centimeter. So in this problem, the refractive index of the glass is not 1.5, it is given 1.55, and all the options given here are very close to each other. So accordingly you have to put this value. You don't take this value 1.5, you have to put 1.55, otherwise you get the wrong answer because all the options are very close to each other. So right option here matches with 3, and 22 centimeter is the radius of curvature of the lens. Let us see the question number 40. Says diffraction effects are easier to notice in case of sound waves than in the case of the light waves because sound waves are longitudinal. Sound is perceived by air. Sound waves are mechanical. Sound waves are longer wavelength. You know, for pronounced diffraction, for pronounced diffraction, dimension of slit must be comparable to wavelength of waves. Since for sound wave, wavelength range, it is 1.5 centimeter to 2 meter. So this wavelength is comparable to this slit, that is windows, doors, or any types of ventilator. So easily sound wave can diffract through these slits normally in our daily life. So this is why diffraction effects easier noticed in case of sound wave, because sound waves are the longer wavelength rather than the wavelength of light. So 4 is the correct option here. Next problem. Ability of eye to see object at all distances is called accommodation. So this is very basic questions asked. Next problem. If the angle of prism is 60 degree and the angle of minimum deviation is 40 degree, the angle of refraction will be. In the case when the prism is placed at the minimum deviation, at the position of minimum deviation, at the positions of minimum deviation, A is the angle of prism, it is the angle of incidence and angle of emergence. When deviation is minimum, we can say angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence. And here the refraction angle at the surface, first surface, and the angle of incidence at the second surface is R2. Since I equal to E, we can say R1 is equal to R2 and it is, let us say, R. And we know R1 plus R2 equal to A. So therefore 2R is equal to A and R is equal to A by 2. If the angle of prism is 60 degree, then the angle of refraction will be, that is 30 degree. Right option matches with 1. Before leaving this question, I must say the minimum deviation equal to I plus E minus A, and this is 2I minus A. So angle of incidence in this case we can say delta minimum plus A by 2. And the refractive index of the prism with respect to surroundings, if I say it is mu, then mu is equal to sine I by sine R, and it is sine delta m plus A by 2, and it is sine A by 2. So these are the basic information at the positions of minimum deviation when light passes through the prism. It is very simple question and basic question asked. Next problem. In young double slit experiment, the slit width and the distance of slit from the screen both are double, the fringe width. What happened to the fringe width? We know fringe width beta is equal to lambda d by d. So new fringe width we can say lambda, slit width and the distance of slit from the screen both are double. D is the distance between slit and screen, it is twice the previous, and it is 2D, that is the separation between two slits. So simply it becomes again lambda d by d. So the fringe width remains unchanged. Option 3 is the correct answer. Let us move the next problem. The torque on a bar magnet due to the earth magnetic field is maximum when the axis of magnet is. We know in any magnetic field, if a magnetic needle is placed at an angle theta, then torque restoring torque we know tau equal to mb sine theta, where m is the magnetic moment and b strength of magnetic field, induction, perpendicular to the field of the earth, parallel to the vertical component of the earth fields, and an angle of 33 to respect with the north-south direction, along the north-south direction. You know, this torque is maximum, that is when theta is 90, the torque is equal to m into b, and this torque is maximum. So right option here is 1. Next problem. A direct current of 2 ampere and an alternating current having maximum value 2A flow through two identical resistances. The ratio of heat producing two resistance is the same time interval will be. It is actually R. In the case of DC source, heat production is equal to, we can say, it is I1 square RT. And in the case of AC circuit, connected across the same resistance, the peak value, here the equivalent virtual DC current in the case of AC source, that is, it is actually RMS. We have to find out the RMS value, RMS current of the AC source. RMS current of the AC source is actually the virtual DC current, that is equivalent to DC current. If we replace this AC source with the virtual DC source, then the current of this AC source we have to take, that is RMS value. and the RMS value given according to this problem, it is equal to maximum current by root 2, you know, and this is given 2 by root 2. Finally, it is root 2 ampere. Therefore, the heat production here we can get, it is I2 square RT. So ratio H1 is to H2 is equal to I1 square is to I2 square, and this is 2 square into root 2 square, 4 is to 2, and finally it is 2 is to 1. The correct option matches here is 3. Or in this way, we have discussed from question number 1 to question number 45 of the mock test 4 platform test series. I hope you are all benefited by this. Best of luck to all of you.